Hey guys, welcome to this channel. Those who don't know me, my name is Vivek and this is my brief intro. Did my bachelor's from University of Delhi. Then I moved to for masters IIT ISM. Right now I am pursuing my masters. I am not passed out yet. So in this channel I am going to teach you the fundamental topics of chemistry as much as I know. In this very first lecture I am going to discuss a very fundamental topic of a general organic chemistry, which is electronic displacement in covalent compounds. So I am going to teach you electronic displacement in covalent compound. Under this topic I am going to teach you resonance, then hyperconjugation, then inductive, and then last mesomeric effect. I hope you heard this name before. So it can be done with reagent and can be done without reagent. With reagent, under this, if pi bonds electrons are moving, it will called as a resonance. If sigma and pi bond electrons in a covalent compound is moving or transferred, it will called as a hyperconjugation. And if only sigma bonds electrons are moving, it will called as a inductive effect. Basically these are the different ways under which electrons are moving in a molecule. And in a without reagent, I hope you heard this name, mesomeric effect. It will done using a reagent. Let's look into it. Let us suppose we have a carbonic compound. Due to electronegativity difference, the carbon center bears a delta positive charge and it has a delta negative charge. Basically we have a electrophilic center here. If a nucleophile will attack, it will attack on a carbon rather than a oxygen. So this carbonyl compound has a delta positive and delta negative charge separated. If we had a incoming nucleophile, then it will attack on a carbon center because LUMO of this carbonyl compound centered on a carbon center. So basically electron density will goes to the LUMO of this carbonyl compound, lowest unoccupied molecular orbital. So this nucleophile will attack on this carbon center. So if nucleophile will attack, this electron density will shift on oxygen. So in this scenario, ultimately electrons are displaced, but we use a reagent called nucleophile. So basically this is a blueprint of mesomeric effect, how it happens. So let's move toward starting from the resonance, because it is a very fundamental topic of a general organic chemistry. I am not going to discuss with definition, you can go through book. So it can be classified further, that we are simply giving names: lone pair pi bond resonance. As the name suggests, the resonances takes place between lone pair and the pi bond of a molecule. Starting from example, we have a molecule CS2 double bond CS2 and has NS2. Nitrogen contain lone pair of electron. So before proceeding toward the resonance effect, we have to see in which molecule it is possible and in which it does not. So we have to see these three conditions first. If these three conditions are followed by a molecule, then it will surely has a resonance effect. So what are these three conditions? First is lone pair must be in p orbital. Lone pair must be in p orbital, not in hybrid orbital, because the lone pair which are in hybrid orbital cannot participate in resonance. not in hybrid orbital. What does it mean? I will discuss later. Not in hybrid orbital. Second, the second will adjacent p orbital should be present, in which these lone pair are moved. Adjacent p orbital. And third is, these two p orbitals should be in same plane. Which two p orbital? The one contain lone pair and the other in which these lone pairs should move. P orbital should be in same plane. Same plane. So we take this example, CS2 double bond, CS2 1 NH2. What if I tell you whether a resonance effect is possible in this molecule or not? So first try to analyze its molecular picture, how it seems, how these pi bonds are formed, and how this lone pairs is present above this nitrogen. So let us take a molecular orbital picture of this molecule. So these two hydrogens are present at carbon, as we know, pi bonds is formed by a sidewise overlapping. So these two p orbital forming a pi bond, clear, and the lone pair present in, let us suppose px orbital, and these two orbitals should be px because these are forming a pi bond. So what I want to say, if this orbital is px, then the adjacent orbital must be px to have a resonance effect, because this move to this orbital and this electron density will shift above this. So how it looks like now, it has a lone pair of electron, CH2 and H2. Now pi bond will form between these two atoms. So this is a general blueprint of a resonance. So another thing to keep in mind is that if lone pair of electron are participate in resonance, it will consider under delocalized lone pair. Delocalized. What does it mean? That lone pairs are not localized above one atom, it is delocalizing throughout the molecule. Clear? If lone pair of electron are not participating in resonance, it means it will present in a hybrid orbital. If its hybridization is, let's suppose, sp2, then it will present in sp2 hybrid orbital, and in this case lone pair are present in p orbital. That's why they are participating in resonance effect. Hybrid orbital. If lone pairs of electron not participating in resonance, then it means it will present in hybrid orbital and called as a localized lone pair. Why I am teach this to you? Because it will help us to determine the hybridization of an atom in a molecule. So what is the general formula of hybridization? It is number of sigma bond formed by a atom plus localized lone pair. In hybridization we does not count delocalized lone pair. So if this summation comes to 4, then hybridization is sp3. If it is 3, it will sp2. If it is 2, it will sp. So let us take an example. CS2 CS2 NS2. So as we know that these lone pairs are localized, these lone pairs are delocalized. So if we are going to calculate its hybridization, so what are the sigma bonds formed by this nitrogen's atom? 2 with hydrogens, 1 with carbon. So 3 sigma bond plus localized lone pairs 0. So the hybridization will comes sp2. Clear? Let us take another example. You tell me whether the resonance is possible in this molecule or not. To predict this, we have to draw first its molecular picture. Then we will able to find whether resonance is possible or not. So let us have a look. As we know that pi bond is formed between carbon and nitrogen, so the p orbitals must be in same plane. So if it is px, then it must be px orbital, and it will form a pi bond. Pi bond formed by a sidewise overlapping. So if px orbital is used in forming a pi bond, then lone pair must be in a px or py and a pz. It can be in py, it can be in pz. So what I teach you, both the p orbital must be in same plane. Which two I am telling of? The lone pair is in py or pz, but the carbon atom having the p orbital is px, so it cannot delocalize from py to px. Clear? So in this molecule there is no resonance, because both the p orbitals are not in a same plane. So if we wanna predict its hybridization, so number of sigma bonds are 1 and 2. 1 and 2. One with carbon and another with hydrogen. So 2 sigma bond. As I told you, if these lone pairs are not involved in resonance, then it will called as a localized lone pair. So it has a one localized lone pair. So the summations comes 3, 2 plus 1, 3. So the hybridization is sp2, and this lone pairs present in sp2 hybrid orbital, because it is not participating in resonance, that's why it is present in sp2 hybrid orbital. Clear?